Hi, in this tutorial, I'm going to show you how to make all these capacitor devices in your PCB software. We have totally 5 different capacitors, all these aluminum electrolyte capacitors being used in the power module. And I think 4 of them have different packages. So let's see how we can make all these different packages in PCB. So first of all, turn on the software. Okay, it's over here. And I will go to libraries. Since I already have all these customized libraries, especially for this capacitor library. So if you don't have that, you can directly right click and actually not here, it's here, and go to new, create a new library. And it's actually here, and you can save it and just name it as, for example, test. Okay. And it's going to show up here. Okay. If you have all these ones, you double click, get into the library, and you can create new packages and new symbols. Since I already have all these capacitor library here in this library folder, so I actually don't need this. I'm going to remove this one, and I will directly double click the capacitor library. I deleted the packages or the footprint I created in the past. So I just trying to make new ones, and hopefully there will be some upgraded ones will be better. So the first thing, there are 2 ways you can make all this footprint. Okay, so the first way, you can draw it by yourself if you couldn't find it anywhere. And the second way is you can directly, for example, you go to here, and you can import it from SparkFun's library. If I click import, and you'll see all these, so all these SparkFun's library. So maybe there will be a capacitor has exactly the same. Actually, it's here. Oh, I should close it. It's just trying to resize it. It's a little bit too big. All right, so just make it here, and so you can keep looking for the correct packages. If you can see one, which is great, like all these ones, right? So looks similar to what we are using, okay, available in the drawer. But however, if it doesn't have the aluminum capacitor you're going to use, then you probably still have to make it by yourself. So if we, for example, if we take a look, let's take a look. 10 millimeter, that's a scale over here. It's hard to tell actually. So if we go back to, for example, let's make the 100 microfarad capacitor first. So go to the DigiKeys website and click this one. So you can see the dimension for the entire package is something around 6.6 millimeter by 6.6 millimeter, I guess. So this 6.6, this is, what's this size here? So 2.6 plus 2.6 is 5.2. And so it's somewhere around 7 already. So it's 6.6 by 7 for the footprint. And so these ones are 0.65 millimeter. So when you are drawing the pad for these ones, if you are using the 0.5 millimeter grade, you definitely are not going to get something like this, right? So because it's going to be 0.5 millimeters multiples. And you don't have to make exactly the same size as the pin. So normally it's a little bit bigger size of the pad is actually recommended. So if you see something around like 0.65 millimeter, I would directly make it 1 millimeter for the width. And for here, you are seeing 2.6. Let's just make it 3. I think it's gonna be fine, not a big problem. So let's go back to PCB so we can see some similar packages. So what I can do is I can, just look at this dimension first. So definitely this is too big. This is 10 millimeter, and this is already more than 10. So definitely that one is not working. This one looks reasonable actually. So see if it has any details. So it doesn't have details for this package. And this looks pretty good as well. So let's go to this one, take a look first. I will double click and let's do a measurement and see if that works. So here you want to change the setting for the grid. And if you set it up every time by yourself, it takes time. So what you can do is you can set up this dimension for once, like what I'm doing here. Okay, so these are the two dimensions, which is the normal grade and also the alternative grade. So this works when you press the ALT push button on the keyboard. So this will be effective. But if you don't push it, then it's going to use this grade. Let's click OK. And since you haven't done that before, right? So what you want to do is you want to right click and new, okay, and name it. So the current grade you are using will be stored in the memory as whatever name you tap to here. Okay, so next time you can directly click, like what I have done here. You can directly click this one. Just going to pick up the one you saved. So all the settings you have saved in this grid function or the module. Okay, so that will make things easier and faster in the future. So now let's take a look. Since we know it's a 7 by 6.6, let's measure that really quick. We're gonna grab the dimension and so it's 6.5, but I think it's pretty close to 7, right? No, so this is 6.6. So actually this is right. And this dimension is somewhere around 7. And I think it's pretty accurate actually. I think we can directly use this one. So let's do that. Since I have loaded this package to my library, so I can directly close it, and you do save, and go back to your Eagle PCB's library, go to capacitors library, so you can see this package has been loaded to your customized library, and you can rename it as, I would just say 6.6 by 7 millimeter, and I think that's fine. So that's a package I want to use. Okay, and for symbol, you can use the same method. You can go back here and import a symbol, since there are only two possible symbols in a capacitors, right? A polarized one or a normal one. And I have 3 here because I made one by myself in the past. But however, this is the one I loaded from the SparkFun's library. Okay, so now you are actually ready for making a device which is 100 microfarad aluminum capacitor. So let's do it. I'm going to go ahead and come to here, and I'll name the device as 100 microfarad 6.6 by 7 millimeter capacitor, right? If you want to make it more specific, you can say ALU aluminum, just AL probably, and OK. So here's a new device, and you want to grab the symbol first. So definitely the symbol should be the polarized symbol. So I will use the SparkFun symbol here and click OK, and load it. Totally depends on you. And I think that's it. So your symbol is done. And then new local package, and use this one and do this. So it's loaded, and you go to connect. But you want to take a look at so they already labeled the name of the pin as plus and minus. So obviously you can make a connection directly, like just plus to plus, minus to minus. I will do connect, and OK, and then save. So now this device is available in the library, so you can use it in the future. So we are done for the 100 microfarad 6.6 by 7 millimeter capacitor. So this one is done. And let's go forward for, so if you go to the package, let's do a double check really quickly. So you can see here, so that's the capacitor we just made. Okay, here's the symbol, here's the package. So that's how you make it quickly. I'm going to show you how to draw it for one of the, the 4 capacitors. But now, as long as we can just directly borrow the footprint or the symbol from the library. Let's just use that one, so it makes things quicker. That's 100 microfarad. So the next one should be 22 microfarad. And let's go to the website first and take a look at the dimension for the 22 microfarad. I'll directly search 22 microfarad. So it's here. So it's pretty much, is that the same package? 0.65 by, I think this is 5.27. Yeah, so I think the 22 microfarad has the same size as 100 microfarad capacitor. So I think you can use the same one. I don't think there's any problem with this. So let's directly grab it. So literally what you can do is create a new device and so name it in the same way, 22 microfarad and 6.6 by 7 millimeter AL, and click OK. Okay, and grab this one and put it here, and then you need a new symbol. Just add a local package, which is this guy, and make a connection between all the pins respectively, and OK and save. Okay, so now the 22 microfarad capacitor is done. So go back here, double click, so you got your 22 microfarad, 100 microfarad. So these are the other capacitors I'm using. These are 0603, this is 1206 package. So we are not using these two. This is for a different project. So, but if you can see that we already have 2 of them already made, and the next one will be what? Will be 33 microfarad. 33 microfarad. Okay. 33 microfarad. We have to go back to the website first and just do a search. So it's here. So if you look at the dimension, okay, so this is a little bit larger. You can see it's 0.9, 0.9 by, no, not that one. So that's actually 8 point. Let's take a look at the 2 microfarad, see if I'm making a mistake here. Okay, so no problem. No, 33. It is 8.3 by, that is 10 point something. So 10 point, no, this is 9.9, 9.9, pretty much 10 millimeter. So that's 8.3 by 10. Okay, if we go to equal, let's take a look if we have something like that. We have to do a footprint first, go to here and import and look at SparkFun's library. So go to the bottom and see if any of them are large enough to make that happen. So it seems like this is promising because it's 5, nope. Yeah, I think this maybe this will work. So let's try it. So let's measure that first. I'm gonna pick up my grade and I will measure it. So remember that's 10 by 8, right? So if this is 8, let's take a look. Okay, so this is 10. This is 10. This is 10. So let's go back to the website. This is only 8. So it's actually a little bit larger than what we need, right? So this should be 10. Let's take a look. What's the dimension here? Okay, must be more than 10 actually. So this can be a good example. So we can probably do something. So this is over somewhere around 12. So this is a little bit too big for our 33 microfarad capacitor. So let's make one in that case. So I'm not going to use this guy. Nope. So hopefully it's not showing up here, right? So it's not showing. Let's make a package. I'm gonna go to here, and I'll make a new package. It's gonna be 8.3 by 10, right? So 8.3 by 10. So I'm gonna do. I will name it as. If you want to make it same name, which is fine, let's do it. I don't know if it's Panasonic, but just make it similar. So you are getting 8.3 by 10, like this, 8.3 by 10. And okay, yep. And don't forget to pick up your dimension, your grade. And so this kind of takes a little bit more time, but I think it's fine. So let's grab a pad first. So actually 2 pads, right? Let's don't worry about the dimension for now. I'm pretty sure we can change it later. So go to website and take a look. What's the size? It's about 1 by 3.4. Okay, so 1 millimeter by 3.4 millimeter. I will do. What about 1.2 by 4? Okay, 1.2 by 4. 1.2, which is right. No. Let's do this 4 by 1.2. Okay, and this one delete. Okay, so normally pin 1 is plus, pin 2 is minus. So okay, so the one has a bar should be plus or minus. Let's take a look. Let's go there. Okay, so this is negative. The black part is negative. So in that case, yeah, so the one on the right hand side should be pin 1, and this should be pin 2, right? And the distance between these 2 pins are what? Let's see. So here is 1.7 by 1.7 by plus 3.1. So it's actually 3.4 plus 3.1 is 6.5. So I will, since this one is at the origin, so this one I'm going to set up a 6.5, right? That's 6.5 because it's 0.4 plus 3.1, 6.5. So these are the 2 pins. And if you look at the other one's dimension, so normally they have a silk screen layer to wrap them up. So you can draw a square to make it happen, or you can draw a circle. But all of them should be on the T-place layer because they are silk screens, like print or paint on the surface. So T-place, and it's going to be a circle. Let's draw a circle first. Okay, so the circle started from. I'll draw it from I don't know, somewhere like this maybe. See if we can make it accurate. Yeah, I think this is fine. Not a big deal. Okay. If you don't make it accurate, which is fine, but I don't think that matters at all. And you need a little polygon to wipe it up. So a polygon can be found here. And I will do this. I'll start from here probably. Since it actually expects you to do this, right? I really don't know if I can do it really well. Two and probably this. Oh, it should be in polygon. Should be a wire. Sorry. So like this, and start from here. Here, and this. Four, like this. Is that right? Close, right? Wait. Oh, I got 5. So nope. Sorry. Okay. Is symmetric? Seems like it's a little bit off. So it should be like this, I think. 2, nope. Still here. 1, 2, 1, 2. So I think it's fine. And now I need to go this way. And actually should stop here. And keep going to here. And then close it. All right, let's just stop here. We couldn't make it perfect. So that's outline of the capacitor. There's a circle. That's the 2 paths. So and then you need a name and value, right? So name on the top, value at the bottom, if I remember this correctly. So we need to go to. We can change it later. So let's just type name, and name is on the top, but however it should be on the T name layer like this, and you need a T value, so it should be on the value layer. Okay, is that right? Let me double check if I have this correct. So let's save it first. I'll come back and revise it. Name on the top, value at the bottom if I'm correct. Yep, so that's fine. Yeah, something like that. So let's go back to here, see the one we just drew, which is this guy. If you compare, actually our path is a little bit smaller than theirs, which I don't think is an issue. You just have a bigger path or smaller path, but I'm pretty sure you are able to solder your path to this easily. If you want to make it larger, maybe let's do it. Let's make it thicker. So it's gonna be, yeah, don't forget to change your grid back to this. And if you want to do 1.5, what about that? Okay. Just want to get more room for the paths. Don't think that's a problem. So let's double check if we have 8.3 by 10. Okay. 9. I don't think that's so 9, a little bit more than 10 and 9. I think that's fine. 8.5 or 9, not a problem. So since when you are placing your parts on the top, you can still see the outline because it's a little larger than 8.3. So I think it's fine. Okay. If you didn't get the correct size, you can right-click the circle and try to change that radius if you like. So you know what? If you want to change it, it's fine. But let's do. I think this is okay because 8.3. If you want to leave a little bit room, so this is actually 9.2, right? So you can still see the circle. Should be all right, I think. Okay, save it. So this is our 33 microfarad capacitor. So go to here, try to make that device. So it should be a 33 microfarad, and this is 8.3 times 10 millimeter AL, right? Create it, and you need a symbol. Grab a symbol. I think we were using this one. Okay, and then you need a local package, which is the one I just created. Wait, oh, we haven't added a description, but I think it's fine. If you add a description, then it's going to show a description over here. Let's add it later. So now let's make the connection. Because pin 1, we put a pin 1 on the right hand side, so it should be plus. Okay, so this is right. Let's double check. I think pin 1 is on the right side. Okay, let's save it. Save. Okay, and now double check if we made it right. Yeah, pin 1 is plus. Okay, so the 33 microfarad capacitor is done. And the very last one, which is a 4.7 microfarad capacitor. So go back to the web page and do Control F, 4.7. So it's here. Let's click, go to DigiKey, and check the dimension for this guy. See if we have a package similar to this or not. Okay. So you can find the package size over here. If you scroll down, you'll see it's 8.3 by 8.3. I think we already had a 8.3 by 8.3 package. But if you want to look at the details, you can go to the data sheet. And this is the code for this capacitor. And if you click this one, you can see this getting to the data sheet. And you can see that CL1, it means, I think it should be this one, because one we have, if you get to the table, you'll see this is A, so A by 6.2. You should look at this column, A by 6.2. And the dimension for this package is actually B is 8.3, C is 8.3. So if you go back here, B should be 8.3, C should be 8.3. So which means CL1 is actually this one. Okay, so this one, you want to actually this one. Okay, you want to look at this one in the table. But anyway, you don't have to come back to here. You can directly see that it's actually 8.3 by 8.3. And if we go back to here and go to capacitors library, do we have 8.3 by 8.3? So we don't have one yet. So you can definitely make one. So let's probably do it. So go to footprint and let's just manufacture 8.3 by 8.3 millimeter, and click OK. Create this package and go back here. So let's create the pad first. Take a look at the pads. So they are H, right? So here's H, here's A, H and A for this one. So it's like 0.7 and 3.3. I think we can do 1 and 3.5. Okay, 1 and 3.5. Okay, 1 and so it's going to be 3.5 by 1. Okay, and make another one, and let's look at the distance between them. So it is E and E plus A, right? So it's going to be E plus A, which is like 5.6. Let's do 7. So this guy, so actually this one should be here because this is plus, this is minus. So this is minus, this is plus. Let's come back and take a look again. E and A, 5.6. So we are doing 6, right? So 6. Right click, and so is that exactly 6. So we don't have to do anything else. And now we need to draw outline. Remember, it's 8.3 by 8.3. We can do 8.5 by 8.5 if that works. So go here and pick up T place and do this. So I want to draw a circle first. What about that? Since this looks a little bit easier. And so because 8.3 by 8.3, so the radius should be, let's do 4.2, for example, or 4.3, maybe 4.3. That works, 4.3, and place it in the middle. And then polygon, no, should be a line, sorry. It's making the same mistake again. So now draw that, see if we can make it looks nice. Probably want to start from here and here, 2, right? Here, 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 here. Okay, done. Save. Don't forget the name and value. So literally this one, this name, add it here, and value here. So change the layer to T name and change here to T value. This one. All right, save. So this package is done. So this is 8.3 by 8.3, and we can definitely create a device using this one, and we're going to name it as 4.7 microfarad, and it's 8.3 by 8.3 aluminum capacitor. Forgot mm. Okay, see if it's consistent with the other names. I think it is. Create. So don't forget to grab this guy, which is a symbol. All right, and then a local package, which is this one, and make all these connections and save, Control S, and come back. So I think we are done with all these capacitors we are going to use for this PCB board. So some of the pins are thicker, some of the thinner, which is fine. As long as you have enough room or space, some redundant space on the side to solder it, I don't think there's any there's any issues at all. Okay, 1, 2, 3, 4. So 4, and 2 of them have the same size, I guess. Okay, that's everything about the capacitors. Hopefully you can, if you see any issues with your design, just directly go back and revise it. Since this is not really hard, if you can probably utilize what has been existing in the Spark Funds library. Actually, if you have made this in the future, you can keep using that. So this is will be always available in the library. Okay, see you in the next video.